My name is Rob Sargis. I'm a clinical endocrinologist and I have a research lab focused on endocrine disrupting chemicals, some of which are found in plastics. So just by way of disclosures, I do some consulting, speaking, also do a little bit of community engagement work. My scientific mission is really to understand how humans alter the environment and how those alterations impact human health. And I'm a physician scientist, so I care for patients. I was in the clinic this morning. So an important focus of what I do is to really try to understand how we can translate knowledge of environmental exposures into action in order to improve human health. We're here to talk about plastics today, and I think that these pictures basically sum up how many people think about plastics. We think about this as a macro problem of plastic pollution that's contaminating our oceans, our land, basically everywhere we look, we see an environment that's contaminated with plastics. But what I want to emphasize to everybody today is what we're really talking about is a diverse family of different risk factors. So those macroplastics that we consider are just one part of this. So these plastics that we incorporate into every aspect of our lives get broken down into these micro and nanoplastics that are increasingly recognized as having potentially adverse health effects. And what's also important is that these plastics are not just a problem because they're plastics, but these plastics are also vehicles of exposure to chemicals that are in those plastics that are non-covalently bound that can alter things like hormone signaling, cancer risk, and all sorts of different adverse health effects. So when we're thinking about plastics, what we're really thinking about is a problem that extends from those plastic bags to their breakdown products, to the chemicals that they're leaching into the environment and into our bodies. So one of the things that sort of drives me is this idea that we have many people in this country who are suffering from ill health. And the question that we face as clinicians is how are we going to best protect the health of our loved ones, our patients, our family members, our communities? And every time I think about this, I think about Fannie Lou Hamer, who, if you don't know, was a civil voting and women's rights activist who gave this famous speech 60 years ago in which she said, "I am sick and tired of being sick and tired." And I think that that ethos is something that we should all be thinking about. And because we all should be sick and tired of the suffering that we witness amongst our friends, our family, and our community. And as such, we need to step up to address those drivers of adverse health that have been neglected for many years. I'm going to focus on one particular disease that I think illustrates the issue of plastics, and it's a disease that's near and dear to my heart because it's what affects most of the patients I see, and that's diabetes. And I'm going to make the argument that diabetes is actually a disease that's amplified by plastics. So we're all on the same page. Diabetes is a disease that afflicts somewhere around 537 million people globally, with 783 million people projected to have the disease by the year 2045. It is not just a disorder that affects folks in the United States and Western Europe. The highest increases in diabetes rates are in places like Southeast Asia, the Middle East and North Africa, and Sub-Saharan Africa. And what's important about diabetes is while we think about it because it raises blood sugars, it's important to recognize that this disease is the leading cause of adult blindness, kidney failure, non-traumatic amputations, and a potent driver of cardiovascular disease, which is what kills most people. And its economic impact is staggering. So other than sort of just the human toll, the economic impact is estimated to be about $413 billion in the United States alone, and it's projected to be over $1 trillion globally by the year 2045. So this is a disease that has immense individual and community and, in fact, global impact. So what's the connection with plastic? So this is a slide that we put together back in 2011. So this is going to illustrate two basic things. So what you see here in red is diabetes rates in the United States from 1958 to 2008. And what you can see is this exponential increase in diabetes rates in the United States, right? What I'm showing in blue is synthetic chemical production in the United States from 1938 to 2008. And there's this little blip downward here in 2008 that is not a reduction in manufacturing that's real. That's just the economic downturn from the recession in 2008. And what you can appreciate from these two curves is how they move together, that the rise in diabetes rates is occurring at the same time that synthetic chemical production is increasing in the United States. Now this is not evidence of causation, right? But it's really interesting to think whether these two things are potentially linked together. And many of those synthetic chemicals are used in plastics or the production of plastics. So the question has become over time, is it possible that these two phenomena linked in time are actually mechanistically linked, that they are associated by scientific evidence that the chemicals that we're putting into our environment are actually contributing to the development of diabetes? So what are these chemicals? So these chemicals are sort of these amazing inventions that have happened since the 1930s. So these include chemicals that are used in food production, so including agricultural pesticides, things like pesticides, food additives, packaging materials. There are chemicals that are generated through industrial activity. They're the chemicals that we choose to use, the chemicals we put on our bodies and use in our homes in personal and home care products. And in a separate thing that we can talk about on the side, there are chemicals that are actually used in medical care as well. But what's important is across all of these classes, many of these chemicals are actually used in plastics. And these include chemicals like bisphenols, phthalates, these perfluoroalkyl substances that are getting a ton of attention. They include things like flame retardants and other chemicals as well. So what we're talking about is a diverse array of chemicals used in a variety of products that could potentially be linked to adverse health effects. And so we're on the same page. This is a slide that I use with students all the time. What is diabetes? So diabetes is an elevation in blood glucose levels that causes myriad problems with health. Normally, blood sugars are kept in a very tight range through the action of insulin. The problem is that most of society is going in the opposite direction. We're sleeping less, we're more stressed, we're gaining more weight, we're less physically active. And what happens is we become progressively more insulin resistant. We move up from point A to point C, and our body's got to fight to keep those blood sugars under control. And the problem is the longer that fight goes on, the more those cells start to fail, and the more you start to deteriorate and your blood sugars start going up. You first sort of enter into this phase of impaired glucose tolerance, in which your blood sugars are high after you eat. And then you ultimately develop what's known as frank type 2 diabetes, in which your blood sugars are high basically all the time. So that's how diabetes develops. So what does this have to do with pollution in any way? The evidence suggests that, and this is evidence from cells, animals, human studies, even clinical trials, have shown that the chemicals that we're exposed to can make the insulin in our body work less well, can drive insulin resistance, and can also impair our ability to make enough insulin to keep our blood sugars under tight control. So what you have are chemicals that hit both of these sides that lead to this deterioration in health and potentiate the development of diabetes. And you may say, well, I'm only exposed to one thing here. Like, does that really matter? But the fact of the matter is each of us has somewhere between 2,000 and 3,000 different chemicals in our body. And you can imagine that a few on this panel and a few on this panel adds up to death by 1,000 cuts. And when you add that to physical inactivity, you add that to weight gain, what you have is a recipe for these environmental drivers to force the development of the disease and potentiate the development of diabetes. So, and this is evidence that's been accruing over the course of the last 20 years. And as I said, robust evidence from cells all the way to humans pointing at these connections. And so the other question then becomes, well, okay, what's the magnitude of this effect? Like, is this really impactful when we think about all the other things that might be leading to the development of diabetes? And I would argue that it is. So the best scientific evidence that we have when we look at population studies in humans are meta-analyses. Meta-analyses that put together a bunch of different studies and basically ask the question, if you're exposed to high levels of chemical A versus low levels of chemical A, what is the risk of diabetes? And what these analyses have shown is that those who are most highly exposed to bisphenol A have a 28% higher risk of developing diabetes. That's pretty significant. Those with the highest levels of phthalate exposures have a twofold higher risk of developing diabetes. And this goes on and on for each of these chemicals. And what's important is that these same chemicals aren't just linked to diabetes, but they're linked to other metabolic disorders like obesity, fatty liver disease, as well as other conditions. And what's important also to remember about this data is that this data is looking at single chemicals or small families of chemicals. It's not taking into account the reality of how we are exposed to these chemicals, which is as mixtures. So if each of these contributes that same type of effect, what you see is a gross magnification of the risk imposed by exposure to these chemicals that are found in plastics. The other thing that is important to recognize is that we're not all equally vulnerable to these chemicals, and there are certain windows of exposure in which people are particularly sensitive. And so this was a patient called me a couple of months ago and basically said, Doc, so this is a patient that I see at the VA. He said, Doc, I know I've been exposed. So he was exposed to Agent Orange during his service during Vietnam. He said, I know I've been exposed, but I want to know what this means to my kids and what this means to my grandkids. And the reason that this is important is that the scientific evidence suggests that when we're exposed to these chemicals in plastic during early periods of life, during in utero life, when we're in the womb, or shortly after birth, that those adverse effects are multiplied. That you can have those exposures occurring early in life that increase your risk of developing a disease later in adulthood, even if that exposure stops. So when we talk about what we're doing with plastics, we're not just affecting individuals, but we're affecting generations. And those generations may experience reverberations of these diseases that go on for generations through through different forms of inheritance. So the other thing is that diabetes is a disease of injustice. So we have known for a very long time that Black, Hispanic, Indigenous, and low-income communities experience higher rates of diabetes than other communities. The other thing is we have known that for a long time, and we still have done very little to address those disparities. Some of those are actually still increasing. So my lab has done a little bit of work to say, well, is it possible that these high rates of diabetes in these vulnerable communities are amplified by higher exposures to these chemicals? And I would say this. These communities not only have higher rates of disease, but they also are more likely to develop the consequences of that disease. If you're Black in America, you are 2 times more likely to die from diabetes than if you're a non-Hispanic. So the question my lab has asked is whether this could potentially be related to exposures to chemicals and plastics, and the answer is potentially yes. So we've done a number of different analyses to show that low-income communities of color have higher levels of exposure to these chemicals. These aren't the only communities that are exposed, but these are some of the communities that experience the highest rates of exposure. So when we think about disease disparities, this is something that has long been neglected and needs to be addressed. So we care, I think, not only because this is a justice issue, but we care because it affects other aspects of this disease. So as I said, I'm a clinician who cares for people with diabetes. We have an increasing burden of a disease that is increasingly expensive and causing significant morbidity and mortality. So the question is, could there be a better way? And what I would argue is when we look at plastics and the adverse effects imposed on our health by plastics, that includes not just diabetes, but disorders like obesity, thyroid disease, fatty liver disease, cardiovascular disease, Why not reduce the risk of all of these by reducing our exposure to these chemicals overall? This has the potential of having myriad benefits to health that extend beyond just one disease, but can help across various aspects of medicine. This is becoming a big deal because we're seeing stories appear in the popular press. So there's an article in The Guardian about microplastics found in every human testicle that was studied. We're finding chemicals from food packaging leaching into food on NPR. You got articles in People magazine talking about plastics from bags and bottles found in every human placenta. And The Atlantic talking about the risks of microplastics. So this was a study that was published this year in the New England Journal of Medicine that looked at the carotid plaques in people with atherosclerosis. And I want to just show you this slide. This is actually just a picture of those plastics in those atherosclerotic plaques. And what I just want to show you over here is that what they did in this study is they compared individuals who had plastic in their plaques versus who didn't have plastics in their plaques. And what they found is those people who had plastics had a 4.5 times higher risk of having a major adverse cardiovascular event. That's a heart attack, that's a stroke, that's a hospitalization for heart disease. So these are even in individuals who have cardiovascular disease. If you got plastics, the risk of a complication of that disease is greater. And we'll need to see replication of this study. This is the first one. But the great thing about this was in the New England Journal of Medicine, which is the preeminent medicine journal. So we're starting to get more attention amongst physicians, which I think will hopefully help. That some of these chemicals that are in plastics that we're exposed to stick around for a really long time. So these persistent chemicals stay in our body despite the fact that we close exposure or end exposure. So there are some tricks that we propose in the paper that may be helpful for reducing the body burden of some of those chemicals as well, that include things like high fiber diets and other things that might be able to interfere with how these chemicals are actually used. And what I hope that you'll get from today is that plastics are not just an issue of waste, but they're an issue of human health. What I really want to emphasize is that unlike genetics, environments are modifiable. We can do something about this. We can choose a better path forward. We just have to do it together. I also just want to mention that we at the University of Illinois Chicago have an environmental health center that puts on talks that you'd all be welcome to attend. You should check out our website. Our center is CACHE. It's the Chicago Center for Health and Environment. It's joint between the University of Illinois Chicago and the University of Chicago. It's a great resource for the community and would welcome any and all of your engagement.